Have you ever analyzed whether we're truly alone in the universe? On the other hand, accepting that there's something else to our reality other than what we see, imagine what is happening if the James Webb Telescope, at long last, shows that we live inside a black hole. It could oblige us as we figure out more about this significant news that will make you question everything you thought you knew about the universe. So, what precisely are black holes? They're like something out of a horrifying dream, sure. 28 seconds you may have seen them in science fiction movies, but astonishingly, they're really frightening. They're not just that. As shown by experts, black holes in space are thought to contain gigantic amounts of matter squeezed into a particularly small area. Consider a star, usually more enormous than the Sun, all squeezed into a circle the size of New York City. The gravitational pull is so strong that nothing, not even light, can escape from it. Experts have been captivated by black holes for a long time. Since then, they've studied objects 1 minute and 2 seconds in space that are so enormous and dense that they can trap light. The most notable ideas about black holes were predicted by Einstein's theory of general relativity. Essentially, when a massive star collapses, it leaves a thick core. If the mass of this core is a few times that of the Sun, gravity overpowers everything, leading to the creation of a black hole. It's no easy task to detect black holes because they don't emit light. However, researchers have found ways to infer their presence by observing their effects on nearby matter. 1 minute and 34 seconds, for example. If a black hole passes through a cloud of interstellar matter, it will pull that matter toward it in a process called accretion. Furthermore, when a regular star gets too close to a black hole, it can get destroyed, emitting X-rays as it does so. Black holes also massively influence their surroundings. They can consume nearby stars, release powerful radiation, and even affect the formation of new stars in certain regions while slowing it down in others. But where do black holes come from? Imagine stars, once large and powerful, 2 minutes and 8 seconds meeting their violent end in a dazzling event known as a supernova. From the remains of these fallen giants, black holes emerge. Most black holes are born from massive stars that have reached their divine retirement party in a supernova explosion. Smaller stars, when they die, turn into what many refer to as neutron stars, which are incredibly dense but not dense enough to trap light. However, if a star is several times the mass of our Sun, it collapses under its own gravitational force, forming a black hole. As these collapses happen, something 2 minutes and 43 seconds strange occurs near their surfaces. Time itself begins to play tricks. From the perspective of someone far away, time seems to slow down near the event horizon, the last boundary for anything falling into a black hole. Perhaps the star's clock ticks at a different speed compared to ours. Sometimes, when two smaller black holes collide, they merge to form a much larger and scarier black hole. And if a black hole interacts with a neutron star, they create a massive nightmare that defies understanding. Scientists have been wrestling with the 3 minutes and 17 seconds size of these enormous phenomena for years. Black holes come in two sizes, large and small. There's an eerie mystery surrounding them that we can't quite unravel. However, here's the trick. Small is relative when it comes to black holes. Extremely massive black holes, the remnants of giant stars, can be as large as 10 to 100 times the size of the Sun. There could be as many as 10 million to a billion of them in the Milky Way alone. That's a staggering number of black holes that could swallow anything in their path. However, wait, there's 3 minutes and 51 seconds something even more colossal. Extremely large black holes are on the far end of the spectrum. They are millions, if not billions, of times bigger than the Sun. They exist at the center of massive galaxies, including our own Milky Way. It's like a massive dead space pulling everything toward it. Renowned physicist Stephen Hawking discussed black holes throughout his life. His talks were always captivating, but some of his theories couldn't be confirmed due to a lack of necessary equipment. But there's hope on the horizon. A single scientific 4 minutes and 25 seconds instrument is making a huge difference, and we're not prepared for it. It's called the James Webb Space Telescope, JWST, and it's here to dive into the depths of our universe. Let me tell you, the JWST is no ordinary telescope. It's an engineering wonder, a testament to the power of human ingenuity. Sure, we've launched other space telescopes before, and they've done their jobs well, but this powerhouse is truly extraordinary. The JWST makes the Hubble Space Telescope, which has served us for many years, seem like a basic speck in the 4 minutes and 59 seconds universe. And the price tag for this astronomical marvel? A mind-boggling $10 billion. Yes, you heard that right. That's enough zeros to blow your mind. Get this, it took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this miracle to life, along with the invaluable contributions of over 300 universities. But let's not forget the risks that come with such an ambitious project. I know this isn't a venture for the faint-hearted. The JWST is venturing into uncharted territory, pushing the limits of what we know and taking us to places we've only dreamed of. After a successful launch, NASA recently announced that the telescope has enough fuel to last more than twice its initial mission life. Since its launch, the JWST has achieved several incredible accomplishments. It has traveled over 1 million miles to reach its orbit around the Sun, where it will remain forever. During its journey, the telescope successfully deployed its massive 5-layer sunshield and giant primary mirror, both of which had to be 6 minutes and 5 seconds folded to fit inside the launch vehicle. Now, after NASA has adjusted and calibrated it, the telescope is almost ready for full operation. One of the most captivating aspects of the JWST was when NASA announced that it had captured its first images of starlight. The first picture taken by the telescope was of a star called HD 8446, resulting in a mosaic of 18 scattered bright spots from the star's light, captured by the 18 mirror segments on the primary mirror. NASA later released another stunning image of HD 6 minutes and 38 seconds 8446, in which the 18 unfocused copies of the star were combined into a deliberate hexagonal arrangement. Once the observatory effectively adjusts the individual segments of the primary mirror, it will begin the process of stacking images, blending 18 pictures into one clear view. Thanks to its cutting-edge technology, the JWST will help researchers study the early stages of the universe after the Big Bang. It will focus on what happened after the first stars formed in a period known as the epoch of reionization. This refers to 7 minutes and 10 seconds, the time when neutral hydrogen was reionized, made to have an electric charge again by radiation from these first stars. This includes looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also aid in discovering exoplanets, which are very hard to detect due to how they interact with their host stars. Its powerful sensors will be able to observe these planets in more detail, sometimes even imaging their atmospheres. Understanding the environments and 7 minutes and 40 seconds of these planets could help scientists predict whether certain planets are habitable or not. In addition to studying the formation of planets, researchers are studying worlds to understand how matter is organized on a large scale. This, in turn, helps us see how the universe evolved and how the twisting and curved galaxies we see today formed from different shapes over billions of years. One of the JWST's goals is to look back at the earliest galaxies to better understand their development. Scientists are also working to 8 minutes and 11 seconds understand how we got the range of galaxies that are visible today and how galaxies continue to form and evolve. But most importantly, the James Webb Space Telescope will help us answer the biggest questions of all. Are we alone in the universe? And are we living inside a black hole? The JWST has already been on the hunt, and guess what? It found compounds called polycyclic aromatic hydrocarbons, PAHs, hiding around those gigantic, very massive black holes in 3 active galaxies. These carbon-based molecules, 8 minutes and 44 seconds with ring-like structures, are the goth kids of the universe. They're everywhere, from distant galaxies to comets and even in our own solar system. Now, they're not just fascinating because they could be the building blocks of life, but also because they help astronomers trace star formation. When ultraviolet radiation hits these PAHs, they glow and emit infrared light, a signal that can be detected by the JWST's mid-infrared instrument, MIRI. This is typically a sign that there are some hot, young stars nearby. But wait for the twist. 9 minutes and 16 seconds inquisitive astrophysicist, Ismael Garcia Bernard from Oxford University, decided to study 3 active galaxies known as NGC 6552, NGC 70319, and the famous Stephan's Quintet, found thousands of light-years away in the depths of darkness. What Garcia Bernard discovered will make your hair stand on end. In the central regions where the black holes dominate, he found a lot of PAHs. Sounds intriguing, right? Well, here's where it gets chilling. The radiation near those massive black holes twisted the PAHs, essentially turning 9 minutes and 50 seconds them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs disappeared into the deep darkness. Imagine being consumed by the darkness itself. But wait, there's a glimmer of hope. Or maybe not. The real question here isn't whether we're alive, but whether we truly exist. Does everything around us exist because of the black hole we're in? Everything seems to align with the theory that perhaps we're not just living inside a black hole, but rather inside the event horizon, a boundary between the universe. 10 minutes and 23 seconds, we know, and the unknown. Could it be that everything is connected within a black hole? The James Webb Space Telescope is out there right now, searching for answers to the unknown. Stay tuned, and perhaps it will make us all reconsider what we thought we knew about existence. Reality may be far more twisted than we realize. In the captivating world of astronomy, few subjects have generated as much interest and mystery as black holes. These colossal entities, with their ability to warp space-time and consume 10 minutes and 54 seconds everything in their vicinity, have long been the subject of both scientific study and popular imagination. The statement that we finally discovered what's inside a black hole, made by renowned physicist Michio Kaku, plays on the awe and curiosity surrounding these enigmatic objects. But what does this bold statement mean? Has science finally unlocked the secrets of what exists within the event horizon of a black hole? To understand Kaku's statement, we need to take a step back and examine the nature of black holes, the current state of 11 minutes and 25 seconds research ***, and the significance of the latest discoveries in the field. A black hole is a region in space where the gravitational pull is so strong that not even light can escape it. This phenomenon is the result of a massive star collapsing under its own gravity after it has depleted its nuclear fuel. When this happens, the star's core contracts, and if the mass is great enough, it forms a singularity, a point of infinite density where the laws of physics as we know them break down. Surrounding this singularity is the event horizon, the 11 minutes and 56 seconds boundary beyond which nothing can escape, not even light. For years, the existence of black holes was merely theoretical. The concept first emerged from Albert Einstein's general theory of relativity. However, it wasn't until the 1960s and 1970s that scientists like John Wheeler, Roger Penrose, and Stephen Hawking began to develop the mathematical framework that would bring black holes into the realm of accepted science. Even with this theoretical understanding, black holes remained a subject of mystery and speculation. What happens beyond the event horizon? Is it possible to peer into the interior of a black hole, or is it, for decades, scientists believed that nothing could escape from a black hole, not even information? This concept, known as the information paradox, presented a major challenge to our understanding of physics. However, recent research has suggested that black holes might not be the absolute voids we once thought they were. One of the biggest breakthroughs came when Stephen Hawking proposed that black holes could slowly emit radiation, now called Hawking radiation. This implied that black holes might not last forever. They could eventually evaporate, releasing their mass energy back into the universe. But this still didn't answer the question: what happens inside a black hole? Michio Kaku's bold statement. When Dr. Michio Kaku recently declared, "We finally discovered what's inside a black hole," he was referring to a combination of new observations, theoretical breakthroughs, and cutting-edge simulations. One of the most fascinating discoveries came from the Event Horizon Telescope, EHT, which captured the first-ever image of a black hole shadow in 2019. This groundbreaking achievement confirmed that black holes have a swirling accretion disk of superheated matter around them, spiraling into the abyss. Then, the James Webb Space Telescope, JWST, added even more intrigue. It detected mysterious structures around black holes, including compounds like polycyclic aromatic hydrocarbons, PAHs, which, as mentioned earlier, might be crucial to the building blocks of life. But what about inside the black hole itself? A window into the abyss. Recent advancements in quantum physics and string theory suggest that the inside of a black hole might not be a singularity at all. Instead, some scientists propose the idea of a holographic universe, where information about everything that has fallen into the black hole is somehow preserved on the event horizon. Others believe that black holes might act as wormholes, connecting different regions of spacetime or even different universes entirely. If this is true, then what we perceive as a black hole could actually be an entry point into another dimension. Are we living inside a black hole? This leads to a mind-bending possibility. What if our universe itself is inside a black hole? Some theories suggest that the Big Bang might have been the result of matter collapsing into a black hole in another universe. If true, it would mean that black holes don't just destroy information but create new realities. This idea is linked to the concept of the multiverse, where black holes might be the birthplaces of entire new universes, each with their own set of